Hello guys, I'm back with a new video. Chemistry! I know we all love chemistry. It's fun, it's cool, it's interesting. Especially all these fun experiments you can do with it. But now, let's go in our topic. Acids and bases. They're a very important concept of chemistry. Acids and bases have definitions. So, one definition for acid is that acid is the chemical which releases H plus into a solution upon dissolving. Whereas a base is a chemical which releases OH minus into a solution upon dissolving. So here you can see that acids and bases are very different. So next we have the pH scale. It is a very important concept of these two. So it goes from 0 to 14. 7 is in the middle. 7, as it is in the middle, it means it's neutral. For example, water. Also, a very important part of our body, which is blood, has also a part on the scale, which is slightly alkaline, and it is 7.4. We also have vinegar, which is a weak acid, and it goes into the region which is lower than 7, which is 4. We also have hydrochloric acid, which is at 3. No, actually it's 1.3. So next we can see we are at a beautiful place where we can also now talk about different examples. For example, that sodium hydroxide is also at 12 and baking powder is at 8. Now we're gonna go into the concept where you balance equations. When you balance equations, it means you're mixing an acid with metal, let's say a different substance, for example copper. Copper and hydrochloric acid, for example, when they mix, they don't really have a reaction. So because you need to have it above a approximate level which will react with the acid. So you have an equation which will have to be balanced. For example, you have magnesium and sulfuric acid. Then you take the numbers and the letters from them. Then you have to balance the equation, which will give you a certain reaction. Also, which is very important, the numbers which are in front of your element are called the so-called stoichiometric coefficients, and they are the numbers which determine how much atoms you have from that element. Next, we're gonna go into our neutralization. Neutralization is very important. For example, when you are in a lab, you want to do an experiment, you also have, for example, some acid and some very heavy alkaline is gonna drop on your hand. You can neutralize it by using an acid which will give the opposite effect of an alkaline and will neutralize the effects. That's why you should always have a weak acid, for example vinegar, when you have an experiment. So if you have an emergency, you can always grab it. Also, there's a very important part in our mouth. When you eat, you have food leftovers mostly in your teeth, which get stuck between their teeth when you eat. Mostly when you eat, you don't swallow everything, which means that parts of it are left, and there are bacteria which feed on these leftovers, and they excrete an acid. This acid will lower the pH in your mouth, which will also then start caries in your mouth, and that's why you should always brush your teeth so that all your leftovers are going to get rid, and also it will make your pH also slightly higher before they actually can excrete the acid. So that way you should always brush your teeth after eating. Next, we have thermochemistry. This is a very important concept. Thermochemistry studies the change in chemical reactions, so the thermochemical reactions, which means heat in chemical reactions. There are two types of reactions. One, there's the exothermic reaction, which releases the heat into your environment. We also have an endothermic reaction, which absorbs heat from your surrounding. Also, there is a reaction, which means it has to happen somewhere, which is the so-called system. In this system, it is the space in which our chemical reactions is going to take place. Also, we have enthalpy, which is delta H, and it is the change in endothermic or exothermic in a chemical reaction. And we also have a graph for enthalpy. For exothermic reaction, it has like a change which is mostly starts very high, then it goes over a curve and then down, and then it is stopped, which means that it gets lower over time, and the space between the 2 points is delta H, and you can calculate it by having your equation, because you have a specific time and then you're gonna divide it also by delta T, and you have the equation Q equals Cm delta T or mc delta T, and this equation is mostly used to then calculate your final result, which is Q. Also, we have in thermochemical reactions, it is very important to know that when exothermic reactions, H plus is usually greater than zero, and endothermic reactions, delta H is bigger than 0. Also, you must keep in mind that heat always flows from hot to cold. Also, I think that when you have the stoichiometric coefficient, you always have to balance your equation there and now again. And this is it.